Good afternoon, friends. In last lecture, we have started Unit 2, that is free electron theory. In that lecture, we discuss about the characteristics of metals. Okay, and after that, we study the Drude-Lorentz free electron theory of metals. Okay, and we have discussed about the basic assumptions of Drude-Lorentz free electron models. Okay, so in last lecture we have studied the free characteristics of metal is that the metal possesses high electrical and thermal conductivity. Okay, this is the first main characteristics, that is the metal possesses high electrical and thermal conductivity. Second is that metal obeys Ohm's law. Okay, it means that in stationary conditions or in steady state, the current density J is proportional. Current density J is proportional to applied electric field strength E. Okay, that is current density J is directly proportional to the applied electric field strength E. So J is directly proportional to E. So J is equal to sigma into E, where sigma is the electrical, this is the constant, and we say that this constant sigma is as electrical conductivity. Okay, this is the second assumption, second characteristics of the metals. And we have learned about the third characteristics of metals is that the ratio of thermal conductivity, the ratio of thermal conductivity K to electrical conductivity sigma is directly proportional to temperature. Okay, so K upon sigma into T is equal to constant. This is the third assumption, and third assumption is known as a Wiedemann-French law. Wiedemann-French law. Okay. Now, after that, we have studied about the Drude-Lorentz free electron theory of metals. In that we study, that is in order to explain and observe the characteristics, that is conductivities of metals, that is Drude and Lorentz proposed a classical free electron theory of metals. So the basic assumptions of Drude-Lorentz free electron model. Okay, so the basic assumption, the first assumptions of Drude-Lorentz free electron model is that is metals are composite of positive ions. Metals are composite of positive ions fixed in the lattice and the large number of valence electrons. Okay, so these valence electrons are free to move throughout the metal, like the molecules of perfect gas, in the vessel. Okay. And second assumption is that the assembly of free electron in a metal is called electron gas. The metal ions are bounded to electrons by an electrostatic force of attraction between their positively charged ions and negatively charged electron gas. And the third assumption is that at ordinary temperature, free electrons are moved in a metal randomly. The free electron move in the vessel randomly with an average kinetic energy is equal to 3/2 kT, like the molecules of perfect gas. Okay. Fourth assumption is that during the random motion of electron collides with themselves and with atoms are ions of the lattice. The electrical and thermal conductivities are mainly due to free electrons. So the electrical and thermal conductivities is mainly due to the free electron. In the absence of an electric field, the motion of free electrons randomly. Okay, in the absence of electric field, the motions of the free electron is random. So therefore average velocity is 0. So therefore the average velocity is 0. If an external electric field is then applied to the metals, the electrons will accelerate and produce a current. When an external electric field is produced to the metals, then the free electrons are accelerated and produce a current. Okay, all these we have studied in the last lecture. So now we study the mean free path. What is the mean free path of electron, or mean free path? Okay, which is denoted by lambda. During the random movement of electrons are collide with each other. During the random motion of electrons, the electrons are collide with each other, or with fixed positive ions in the metals. Okay, after every collision, the electron assumed to start. After every collision, the electrons are assumed to start moving in a few directions. Suppose after a collision, electrons are moving in a few directions with zero initial velocity. Okay, when the electrons are collide, then the initial speed is 0. Then after collision, these are moved to start moving. Okay, are the new direction with zero initial velocity. So the mean free path is defined as the average distance traveled by an electron. The average distance traveled, that is what? The average distance traveled by electron, an electron between any two successive collision. Okay, between any two successive collision in straight line. In the absence of electric field. In the absence of external electric field is known as mean free path. Okay, what is mean free path? Mean free path, that is the average distance traveled by an electron. Average distance किसने travel किया? The average distance traveled by a free electron or an electron between any two successive collision. In straight line. In the absence of external electric field is known as mean free path. Okay, what is mean free path? The average distance traveled by an electron between any two successive collision in straight line in absence of external electric field is known as mean free path, and it is denoted as lambda is equal to small v into tau. Okay, where tau is the time between two successive collision. It is the time between two successive collision, and V is the average thermal speed. V is the average thermal speed of an electron. Average thermal speed of an electron. Okay, this is about the mean free path. Okay. After that, we see the drift velocity. Okay, drift velocity. Drift velocity. And drift velocity is denoted as V suffix D. Okay, this is the drift velocity. When an electric field E is applied to the metal, when an electric field is applied to the metal, motion of the electron is modified. When we apply an external electric field, then the motion of the electron is modified, and the electrons acquire an acceleration. So this acceleration A is nothing but the force upon mass. Okay, the force upon mass, and force is denoted as, that is, E into capital E into, where E is the electric strength, this is the mass of electrons, so this is M. Okay, so E, this is the charge of electron, E into capital E into upon small m. Okay, so velocity acquired by an electron due to application. So velocity acquired by an electron due to the application of electric field is the V is equal to U plus AT. Okay, that is U plus AT. After each collision, the electron starts moving. After each collision, electron starts moving in a new direction. Electron starts moving in a new direction with zero initial speed. So initial speed, so U is the initial speed. So after every collision, it starts to move in a new direction. So initial speed of the electron U should be 0. So what we get? That is V is equal to 0, and here acceleration A is nothing but E into capital E upon small e into T. Okay. Here T is the time interval between two successive collision, which is represented as tau. Okay. So applied electric field E accelerates the electron. Applied electric field E accelerates the electrons. The electron velocity suffers a sudden change in magnitude. So electron suffers a sudden change in magnitude and direction. The net movement is called as drift velocity. Net movement is called as drift velocity, or drift. Net movement is called as drift, and the corresponding average velocity. Then the corresponding average velocity is called as drift velocity. Okay, the net movement is called as drift. Okay, and the corresponding average velocity corresponding average velocity is called as drift velocity. That is V. Okay. So when we apply the electric field, due to the applied external electric field which accelerate the electrons, the electron velocity suffers sudden change in magnitude and direction. The net movement is called as drift, and the corresponding average speed or average velocity is called as drift velocity. So Vd is nothing but the initial speed, initial velocity plus final velocity final velocity before collision divided by 2, okay, that is initial velocity plus final velocity before collision is equal to t. So initial velocity is equal to 0 and final velocity is, that is final velocity before collision is, that is plus e on m into t divided by 2. Okay, so final drift velocity Vd is represented as, so I write here Vd is equal to E, capital E upon twice m into t. Okay, where E twice m, E into capital, sorry, E into t upon twice m is equal to mu e, and this is nothing but the electronic mobility. It is called as electronic mobility of an electron. Okay, so here E upon t upon twice m is equal to mu e is called as electronic mobility of an electron. So drift velocity time of drift velocity is equal to, that is v something z is equal to E upon t upon twice m is time mu e into capital E. This is the drift expression of drift velocity. Okay. So in this lecture, what we have study, that is mean. What is mean by mean free path? Okay, what is mean free path? The average distance traveled by an electron between any two successive collision in a straight line in the absence of external electric field is called as mean free path. And after that is mean free path is equal to what? Lambda is equal to small v into tau, where tau is the time between two successive collision and v is the average thermal speed of an electron. After that, we consider that is the drift velocity, and we find out the drift expression of drift velocity, that is Vd is equal to mu e upon plus e. Okay, thank you.